All right, this is Revamping Your 10-Year-Old Nagios Installation. Please welcome Mike Guthrie.
All right, well, thank you guys for coming out today. I know at this stage of the conference, it feels a little bit like you've been drinking from a fire hose for 2 days, so I appreciate you guys hanging in there and coming out after lunch, and I'll do my best to keep you awake so this doesn't turn into nap time. As I said, my name is Mike Guthrie. I used to be a developer at Nagios Enterprises for about 3 years, and 2.5 years ago, I took a job down at Red Ventures in North Carolina. And I was a software engineer down there for about 2 years, and then back in March, I got hired as a DevOps engineer there. What Red Ventures is, it's a digital marketing company, and what we do is we have a customer acquisition model. The idea being that if we partner with a client, we're going to acquire customers for you, and we get paid when we deliver customers. We do this two different ways. One is through search engine optimization. We basically will run your websites for you and just generate more traffic. The other way that we do this is with our inbound sales center. We take your call volume, and the idea is that you send us your call volume, and we will convert at a higher rate than you will. I know when I was on the insurance division, there was one partner that was doing a call test with us, and they were converting customers at around 10% or so. And after about 3 months of us kind of working through the sales process, we were converting at about 25%. So this is a model that's proved very successful for our company. We're only about 10 or 12 years old, and there's 2,000 people currently working for Red Ventures. And we just built Building 3 of our campus, and we have, starting in about the next month or so, we're going to be breaking ground on Buildings 4, 5, and 6. So it's growing very, very fast, and we're a very fast, agile company. And as far as the technology backend behind this, we're very, very technology driven. We work primarily on a LAMP stack. Our language sets are primarily PHP and JavaScript. We're moving a lot towards Node.js applications. But we love data. We log everything. We record everything. Everything's in a database. We use MySQL for that. But we have tons and tons of storage across our various businesses within the company. And like I said, we move fast. Think agile development on steroids. Our developers meet with the business teams. There's no actual project managers. Just every week they sit down and they get together and plan out their sprints for the week. And there's very little red tape. It's like, here's what we need. We need you to do it. And developers they have a lot of freedom to just basically go after it and just build whatever people ask them to build. And that part of it's very fun because there's not a lot of bureaucracy there. They just say, hey, here's what we need, and they give you creative freedom to go build it. Downside of that is because things move so quickly and there isn't project management, there are times where that, as you can imagine, might create a certain amount of technical debt. Or at other times you build something and they use it for a week and they're like, this didn't turn out the way we wanted, so let's throw it in the trash and build something new. So you kind of learn to detach yourself emotionally from things you built and just learn to just work on your engineering skills and build things that way. So another thing we're a huge proponent of is redundancy. We have 2 data centers, one in Charlotte, one in Atlanta, and we cluster pretty much everything. So if we spin up a database for a new business, we don't spin up 1 server, we spin up 5. 3 will be in Atlanta, 2 will be in Charlotte, 1 master that replicates to these others. And we run our web servers the same way. So essentially everything is clustered. So when I got the DevOps position back in March, one of the key things that they needed was somebody to work on infrastructure monitoring. Basically, it was a complete and total mess, and they knew it, and they were just at a point where, like, we don't have time or the expertise to deal with this. You used to be a Nagios developer, here. And they're like, you do something with it. And so at the time, we had 2 different Nagios installations. We believe in kind of monitoring at the locations that our data centers are because we don't want to lose connectivity between the 2 and make it look like half our infrastructure went down when it really didn't. And at the time, we had 1,100 hosts, about 8,000 services. And just to give you a perspective on how quickly we're growing, right now, we have about 1,600 hosts and about 14,000 services. So that's just in about 6 to 8 months, we've added that many hosts, and we continue to grow at that rate. Primarily, we're using Linux servers for web servers. We have MySQL servers, cron, and load balancers. We also have Windows servers that host all of our phone system software. So all of our calls come through. And we also have Windows terminal servers that all of our sales agents use for the actual call center software. And then, like any network, we have routers, switches, and so forth to power all of that as our network backbone. At the time, they were using PNP for Nagios for the performance data and Thruk UI to tie the two instances together. So some of the key problems that they had with the monitoring infrastructure when they gave it to me is I kind of went through and did an audit of everything, and it was impressively messy what they'd given me. And having done support for Nagios, I got to see everything from like amazingly organized and outstanding installations of Nagios to complete messes, and we were way over on the side of complete messes. You could actually see the evolution of config management for the last 10 or 12 years, where things that were very, very old were all kept literally in one services.config file. And it didn't matter if it was a host group, a service config, an escalation, or a dependency. Like, they were just throwing everything in that file. And then things, after a little while, they're like, oh, maybe that isn't such a good idea. Let's put everything in kind of one-off host files. So they had a host with all the service definitions in it. And then later on, they attempted to do service to host group assignments, but they did it in such a way where it was completely inconsistent between Charlotte and Atlanta. And basically, when I came on board and they would ask for a config change, they would say, oh, hey, we want this check added to every single Linux server. It would take me like 2 days to like hunt down every last Linux server and make sure that that check got added everywhere, because I had to grep all over through the files, and it just meant touching hundreds of files. And it was very, very cumbersome to work with and just really, really difficult to manage. And especially as we continued to scale, it just got harder and harder to make changes with it. Another key issue would be just terrible alert storms. There were no real dependencies set up, and everything was a notification interval of 5 minutes. So of course, if your disk was filling up, and it's not a huge priority, you still got 20% left, you're still gonna get a notification every 5 minutes. And it's like, I mean, people were getting thousands of emails a day, and they had just come to accept that as normal. And just because of the speed of growth and how fast we were spinning up servers, they weren't even able to keep track of everything they were spinning up anymore. There were load balancers, there were all kinds of things that were just kind of out in the wild that they had completely been forgotten. They weren't even being monitored at all. So a couple other key issues I ran into was the Atlanta server had some serious latency problems, as well as broken escalations. I discovered later that those two were actually connected. Somebody had accidentally put a backtick in the escalation notification command. So when alerts were supposed to go to pagerduty, what it really did was open up a pipe on the, in the Nagios process that basically stalled out the Nagios event timing loop. So in a real outage, when people are supposed to be getting alerts on their phone, instead what was happening is that Nagios would basically crap out and fall farther and farther behind, to where people would finally get their alerts probably like 30 minutes after the outage was over and resolved. So it was pretty special. So, and then the other thing we had is we did have performance data with PNP, but because everything is in a cluster, it just didn't really give us a very good view of what we needed to see. So it was in such a messy, terrible state, and they were so fed up with it. I was able to come on board, and they were just like, Mike, whatever you want to do with this, go ahead and do it, which of course is what every single engineer dreams about hearing, is saying, green light, build whatever you want to build, just make it good and fix this. So being a former Nagios developer, I'm like, this is awesome. I couldn't ask for a better situation. This is great. So I got to have a lot of fun. I'm just going through and kind of evaluating different ways that we could approach this in our environment. Some of the key goals that I came up with was, number one, manageable configuration. That mess that we had before, I'm like, we're not going to do this again. We have so many things that are, with all of our clusters, we'll have 5 hosts that are exactly the same. It's like this should, in theory, be easy to manage. We should be able to have some easier configuration management, just because there's so many of the same things in our environment. I wanted to just minimize the time spent on maintenance. I didn't want to be spending 10 to 20 hours a week managing config files anymore. I believe that we don't have to. And then some level of improvement on just our reporting, visualization, dashboards, because there's very little of that at the time. I also wanted to be able to scale, because we continue to grow at a rapid rate. I didn't want to have to worry about scaling out our monitoring servers. I just wanted to be able to handle stuff for years, that we could just continue adding more hosts to it, and they would run smoothly. Noise reduction is something that pretty much anybody who has to manage a Nagios installation has to deal with that issue and wrestle with it and continually manage it. And the other thing is that we just fired up a new NOC team, which consists of 3 people, and they're not Linux admins or sysadmins. They are people that kind of primarily field communication, but we needed to present outages to them in a way that they could understand and actually know who they need to correspond with in the event of a real outage. So step 1 of gutting this whole thing, and just kind of as a context for how this was done, is that I did not touch the existing monitoring servers when I began work on the new ones. We said, you know what, we're going to leave these running, we're going to leave them right there, we're not going to touch them, we're going to spin up 2 brand new instances right alongside of them, and we're going to do all our work on these new ones, and we're not going to break any of our existing setup right now. So with the new ones, I created a new setup where anything that was basically a location agnostic, so things like contacts, templates, commands, host groups, escalations, and dependencies, all of these things can and should be the same no matter what location you're at. And so I set those up in a way so that it didn't matter what site they're on, they should always be exactly the same. So between Charlotte and Atlanta, these things are the same. They are now version controlled and they're synced. So anytime I need to add a new contact or I add a new host group, I'll just make the change on one, push it up with Git, pull it down with the other, and restart Nagios on both machines, and they're always in sync. And I don't have to worry about what got changed over here and how far is it diverting from the other server over there. Things that are not version controlled, that I keep kind of decoupled from each other, would be host files. I have a host directory, and every single host gets its own file, which lends itself really well for automation, so that if we ever automatically add a host, we just drop a file in that directory. Nagios will pick it up. If we ever need to remove a host, whether through an API call or whatever, we'll just pull it from that directory, restart Nagios, and so hosts can be added and removed, and we don't have to touch any other configurations because they stand alone on their own, and they're not connected directly to any of the host groups or otherwise. So the other part of fixing the configuration management, everything's using a template as much as possible, and then all of our services are applied through service to host group relationships. And the idea that I had was, let's make host groups more like monitoring attributes, and not so much like a specific, just these types of groups, because we have so many different types of groups, but really it was almost always the same types of services that needed to be monitored. And if you're a Linux server, you should get standard Linux checks. If you're a MySQL server, you should get standard MySQL checks. Some of the MySQL servers are slaving. And so if you were one of those, you needed slaving checks. So the idea I had was basically a host group would represent some sort of a monitoring attribute, and you would basically create layers of host groups to ultimately build a monitoring profile for a particular host. So for example, I've got in here like a standard thing for one of our MySQL slaves is that you are a Linux server, you're a MySQL server, you're a MySQL slave, and you're MySQL hardware. And each one of those groups, some of those groups only have one check for that group. But the issue that we ran into is that if I want to change that one check, I want it to apply everywhere, and I only want to change it in one place. So that was the idea behind that. The other thing is that some of our hosts had differences in perhaps the port that a particular service was running on, or for using SNMP, we would have a different community string. I just created those as host variables, and the templates would have kind of the default values, but if anything strayed from that default, I could just override it at the host level. So the next portion of this was config automation. Me being a typical DevOps engineer, I love all things automation. So the idea was that I'm like, okay, we're using Puppet right now. There's got to be a way I can tie into Puppet and have Puppet know what these monitoring attributes are supposed to be for every single server, because a server will know what's installed on it. Somehow we should be able to either propagate that up to Puppet or enforce that down from Puppet and be able to figure that out. And in building all of this, right about the time that I got all of this launched in our new servers, they said, hey, you did a great job doing this Puppet. By the way, we're going to switch to Salt Stack, so we need you to re-implement everything you did in Puppet and do it in Salt as well. So, and that was several months ago, and we're still partially transitioned, that whole technical debt thing. We haven't finish that migration. So we have both running. For some servers are using Puppet, some servers are using Salt. But the process I'm going to describe here is set up for both Puppet and Salt. But essentially, it's based around the fact that any machine will know what services are on it, and it should be able to be somewhat self-aware of what needs to be monitored on it. And so what we did is that, I'll actually go into, all right, let me go back here. Essentially, we're using passive checks to basically, a server will propagate itself into Nagios, and I'll describe in just a moment how we're doing that. But just to give you guys an idea for the difference that it made in terms of our configuration management, on the left here, this is what you would see previously of a typical host file. Lots of information in it. A lot of times it would be copied and pasted. Some things would be changed, and there was just a whole lot of inconsistency. It got to be really hard to manage. Now our host files look like the one on the right. It's just a host definition, a template, and a list of host groups, and maybe a host variable if we need to override something for that host. Everything pretty much looks like that. If we need to add new checks to a host, we'll add a new host group to it on top of that. Occasionally there'll be a one-off situation where I might add 1 or 2 services that are actually a one-off scenario for a particular host, but that's about 1 or 2% of the hosts where we have to do that. So I'm going to subject you to one of my horrible flow diagrams that I draw, and this is trying to just outline how we set up the automation. So everything kind of starts with our config management software, whether it be Puppet or Salt. It's set up very similarly for both. And essentially, when a new server is spun up, the config manager will enforce what a server is supposed to have on it for NRPE and for the passive checks. It's saying, okay, you're this type of server. You need to have all your standard Linux checks on there, and then whatever specific checks you need that correspond to your monitoring profile. So these passive checks will start shortly after the server spins up, and it will start firing its checks at the location-specific Nagios server. I added a custom webhook in here that these checks, the passive checks, just basically fire with a simple curl post. They just post the host name, service description, status, and the plugin output to a custom webhook that I wrote. And all this webhook does is it checks to see, okay, does this host exist? And if it doesn't, let's go talk to the config manager and say, what host groups are you supposed to be in? And it pulls down that list of host groups, generates a host config, drops it in the host directory, restarts Nagios. And if the host does exist, it just processes the check result normally. It's kind of a splice of Nagios and our DP. I use the same kind of concept where it receives the data and then just drops the check result directly in the check results directory, and the Nagios engine just picks it up and reaps it and pulls it in. Now, and with that, there are some safety nets in there too, where it adds the host, it will verify, and if the verification fails, it doesn't actually restart Nagios. But otherwise, we've had this running for several months, and when we launched this, it was a pretty cool thing. The day that I had done my successful pilot tests and so forth, and we turned this on in our environment, and I got to sit back and watch between 300 and 400 Linux hosts just simply add themselves to my Nagios servers. And it was kind of fun to just watch them all come in and everything set itself up. And since then, we've had it running, and I have it set up now where it just sends me an email notification saying, hey, a new host was added to Nagios, and here's the config it generated, just as a way to kind of audit and make sure that it's still running the way that it's supposed to going forward. So the result of all of this, number one, consistency. This is a huge deal, and it was a major source of frustration in the past. And so we definitely achieved that goal, is that things are consistent. It's much easier to manage now. And we do have Linux or Windows hosts as well that we don't have them auto-generating, but almost all of our Windows hosts are either terminal servers or phone servers, and they can almost always be cloned. Very rarely do we need to set up a brand new monitoring profile for a Windows server. So we do have a simple web tool that will basically say, okay, copy from this host, here's my list of new hosts, and all it does is just a search and replace of the host name, drops files in the host directory, restart Nagios. What this has done between the automation and the kind of organization of the configs is it's taken our maintenance time from about 10 to 20 hours a week down to about 1 to 2 hours a week. And most of the time, if it's more than 2 hours, it's because we have to establish a brand new monitoring profile for something that we've never ever used before. But most weeks, it's very, very minimal time that we spend maintaining, and a lot of the maintenance now is just trying to stay on top of notifications and alerts and make sure those don't just kind of degrade and get to where they're no longer relevant. So the next step that we had was just we needed some way for improved reporting and visualization, and we needed a way for the NOC to be able to kind of see when there was some sort of an issue. The other thing is that because everything runs in a cluster, just being able to view performance data as a cluster was really, really important to us. And there was requests as well to just be able to view historical state changes and notifications, because we always wanted to make sure, like, hey, there was an outage. Did somebody actually get the notification that they were expecting to get when we would have expected it? And so for that, this is just kind of an outline of the different servers that we're using for our monitoring setup. So we have Nagios Core in Atlanta, which all that's doing is just doing checks and alerts. And Charlotte's doing the exact same thing. And they both send their status data off to NDO Utils, which is offloaded on its own server. And then something else that I've got these servers doing is that they are sending performance data offloaded to a Graphite server, which basically I just have everything going across the network using a socket connection, and I'll get into that more in just a moment. But I wanted to have all that offloaded on its own server, and honestly, I'd never used Graphite before, heard a lot about it, figured I'd give it a try, and it seemed like a great way to get performance data off of the Nagios server. There are things I didn't especially love about PnP for Nagios. I didn't love how much CPU and disk utilization it put on there. It's a pretty heavy load it puts on the system. And there are some other things about it too, of just like if you ever add a data set to an RRD file, it has to regenerate the file and blows away all your historical data. Whereas the storage that Graphite uses, you can add new data sets to it and it will maintain your data and you don't lose it anytime you change something about your check plugin. So the things you're seeing here is that what we put in front of our performance data server is an application called Grafana. And that basically is a tool that allows us to build and combine performance data in whatever way that we need to. I'll dig more into that in just a moment. And then for NDO Utils, what we put in front of that is just a simple dashboard that's just showing here's all of our unhandled problems. Here's the host groups, or I'm sorry, here are the contact groups for this particular machine, and here's how many notifications have gone out for this particular service. This is basically just built purely to be a NOC level view, so they kind of know what's going on, have they been notified, and who should we call just in case this issue seems to be persisting and nobody's responding. Here's a zoom in on the Grafana dashboard, and these are things like, for example, our external web servers. We're able to pretty quickly identify anomalies and things like that when we view the entire cluster together. And I'll dig into this even some more a little bit later here. So one thing I've learned through all of this is a combination of Graphite and Grafana has been amazing for us. What I did for, as far as shipping this data off to its own server is there was a open source application called Graphios that ran as an external daemon that would take your performance data and ship it off to another server. There were things I didn't especially love about it, and actually now that we live in a Nagios 4 world where Nagios 4 has workers and it's not running on one synchronous event timing loop, you could actually you can send things directly off to another server, and you don't have to worry about blocking the main event timing loop because things are running asynchronously now by workers. So you have some more options now with Nagios 4. And what I love about the Nagios core engine is that if you know where things are, there's so many ways that you can connect into it. And so what I did was that I thought to myself, I'm like, okay, there's got to be a way to ship this data off that can just be built right into the core engine, and it can just, as long as it's fast, it's not going to block things up on the main server. So what I did was I just wrote, there's a config directive in the main Nagios config file called service perf data file template. And all that's doing is it's saying, okay, for performance data, just drop it to this file in this format. So then what I wrote that was custom is that there's a service perf data file processing command, if you can remember that terrible directive name. But all it is just saying, okay, every X number of seconds, run this command, And so what all that command does is it goes against the performance data spool file, and it goes through and processes it, and it just does whatever you want with it. So my custom command basically takes all that buffered performance data. All it does is it just moves it over to a temp file, goes through and processes it in a way that it can just ship it off to Graphite. And all I'm doing is a very simple multi-line socket write over UDP, and just doing socket write, and it sends it across. And because it's UDP, it's extremely fast. So I'm able to send, I would say my command runs about every 10 seconds, but it's able to send all of my performance data in about 30 milliseconds across the network to my server. So it's basically, there's like no real delay for the Nagios engine in terms of sending off the performance data. So what's great about that is that there's no real performance load against my Nagios servers doing it this way, because all the performance data is being processed somewhere else. And one other thing I've noticed about Graphite and Carbon, which is the back end for it, is that is an application that can scale like way beyond anything I've been able to throw at it yet. I've purposely tried to bomb it with data just to see what I can do, and I can barely get the load to shoot above like 1.5 for more than a couple seconds. I've literally tried to take it down, and I can't. So it's pretty impressive in terms of scalability. So the front end, Grafana makes building custom performance data dashboards easy. And if anybody's ever tried to do custom RD templates, you'll know that it's painful and it's really hard to work with. And this is extremely easy because it basically lets you pick out your performance data from drop-downs. You can use wildcards and matches and so forth. And so it lets me say, okay, I want Atlanta, DB servers, CPU load, everything CPU load 5. And you can say I want DB, ATL, wildcard, and it will grab all of my database servers, 1 through 30 or whatever it is, and it will give me CPU load on them. It'll give all of them in a list on the same graph. Or if I say I want the average of all of these, and it allows me to do that. Or I can say I want a 30-minute roll-up of, I want to know what the 30-minute rolling average is of all of these. And you can even do diffs from one series to another. A lot of really cool stuff that's built into it, and it's been super, super valuable for us because it's let us see and build kind of aggregated dashboards so that we actually know what's the health of our cluster, and lets us see that very, very easily. The other key item is that because we are in such a fast, agile development environment, is that I would say about once a month we have some bad code that goes out, and we can watch on our graphs. We can actually see on our rotating dashboards, and we're like, hey, pod 8's freaking out. Somebody just deployed some bad code. Let's go send some emails, find out what just happened. It's been extremely valuable to us to see. So here are just 2 examples of graphs that we put together. So we have our internal intranet, which is about 30 servers as a cluster. Even though it has a huge amount of change in the CPU load throughout the day, it's completely normal. We expect it. We give it a pretty wide threshold, but we can see on the graph, okay, this is normal, just normal everyday traffic. Even if it spikes up into the warning area, it's like not a big deal. It's within like the normal range for what it would do this time of day. Whereas the graph on the bottom, that is all of our different pods averaged together for their CPU load. So we can actually see, okay, this line in the red, which is pod 8, somebody just deployed some bad code because it is completely outside of its normal regression line for this time of day. And it's completely outside of every other pod. We know this is only happening on pod 8. Somebody's deployed business-specific code to these servers that is just totally causing the CPU load to spike and go out of control. It's done a lot in terms of the event correlation, helps us narrow down the cause of issues in our environment. So where do we want to go from here is that the Graphite and Grafana combination has been so effective for us. We're like, hey, why don't we just start feeding other stuff to it? So we started experimenting with feeding application-specific metrics to it, and even business-specific metrics of things like, we want to just watch our call volume with it, because we can actually compare and see how does our call volume look today compared to last week and the week before and the week before that. And we can actually see, hey, there's a weird dip going on today or a weird spike going on today. Something unusual is happening. We should figure out what's going on with that. The other thing we're going to do shortly, I'm in the midst of building a new deployment system, and one of the things that's going to have is it's actually going to feed timing markers for when our deployments go out. So we'll actually be able to trace and say, okay, on a vertical line in this graph, I can see that the CPU load spiked out and somebody made a deployment right at this time, and it's this deploy ID. Let's go back and see what somebody pushed. And then something else that is completely experimental, we have not tried at all, but it's kind of our next phase where we want to take things, is Etsy's developed something called Skyline and Oculus. And it's basically an anomaly detection system, and it's built to feed off of the data that's in Graphite. And it basically just crunches on the performance data, and it looks for unusual anomalies for that time of day, day, week, and so forth. And the idea is that it will alert on those and also potentially alert on anomalies that might be related to each other. Now, I'll say up front as a disclaimer, we have not even installed this yet. It sounds really cool. We're going to try it. I have no idea if it will actually be effective in a real-world use case, but that's where we want to head from here, because we have a lot of situations like what you're seeing on these graphs right here, is that there's a huge amount of difference in CPU load at 9 in the morning versus 4 in the afternoon. Normal at 9 in the morning is a CPU load average of less than 1, where at 4 in the afternoon, it's completely normal for it to be around 30. But if it was at 30 at 9 in the morning, something's seriously wrong and we need to take a look at it. We need some way to get around using just static thresholds and be able to kind of watch for things that have very normal swings, but they're very, very dynamic swings. As far as our implementation of this, we left our old servers alone and running. We didn't touch them at all. We spun up new servers alongside of it, and the actual basically switching it over to the new servers, it consisted of, okay, turn off notifications and event handlers on the old machines, turn them on the new machines, and point Thruck at the new servers. And that was it. And so as we were migrating configs over and everything like that, I mean, it was one thing that's great about Nagios, it will tell you exactly what's wrong. So as we imported configs, we could totally see, I'm like, okay, well, we don't have IP access to these machines and this and that. So it would just basically tell us all the unhandled problems that were on it. And so it let us see kind of side by side, okay, it's working on the old servers, it's not working on the new servers. There's just some things that we have to work through and sort out. So running those in parallel for a while was extremely helpful and useful. And we actually left the old servers running for probably almost 2 months after we rolled to the new ones, just as a reference to go back and look and be like, hey, did we miss something somewhere in all of this? Because one of the other things I had to do was migrate about 600 host files by hand, which was not awesome. But you know, if you really want to clean up your environment, there's some parts of it that there's no better way to do it. You're just going to have to go through and make sure you don't miss things, because that was one thing, is that we couldn't lose monitoring that we had before and lose track of things that we used to be monitoring, we used to be able to depend on were there. So the actual config migration took about 6 weeks, and that was amidst other things I was doing it for my DevOps responsibilities. And then the full kind of review, migration, and implementation with performance data and all that, the whole process probably took about 90 days. We're kind of mostly in maintenance mode right now, but again, we're starting to explore different options for how to take things further and move towards anomaly detection and things like that as well. So that'll be, hopefully in the next few months, we'll get to tinker with that, and maybe next year that'll be a presentation topic, so we'll see. So things I learned out of this whole process, number one, if you are handed an infrastructure monitoring situation, or you're put in charge of Nagios, number one most important thing I could suggest is take the time to understand what you're monitoring. If you don't understand what a machine is supposed to be doing, you're not going to be able to monitor it very effectively. And if you don't understand its behavior and what's normal, it's going to be, you're going to end up with a noisy system, and it's not going to be ultimately as effective as what it could be. If you don't have a good understanding, things are going to be noisy. And one other thing in terms of, you saw my arrows going all over the place with my diagram. It's a complex system. The way I approach complex systems is log everything and assume every step will fail. And if something does fail, make sure your logging tells you exactly what failed. And so even though I have a automation system in place that has tons and tons of moving parts, I always know, like if anything goes wrong, I always know exactly where it broke specifically, and I can trace it back because I get absolutely ridiculous with my logging. So, small changes do the most damage. A lot of you guys in the sysadmin world have probably experienced such a thing. And automation is really, really cool, except for the day when it automatically sends like 60% of your environment into a CPU death spiral, and you almost take down the entire infrastructure because you put a bad check command in your nrp config. So that was a pretty fun day. So I deployed like this new check command they were adding to our servers, and like, yep, no problem. I kind of watched it for like 30 minutes. Everything was fine. And then about another 30 minutes later, I start seeing CPU load climb across the board, and it keeps getting higher and higher and higher. And I hop on one of these servers, and I see one of my check commands has somehow stalled out and left open as a hung process. So my 3-minute cron job that was firing passive checks decided to stall out and stack up. So by the time I hopped on one of my servers, there would be about 25 versions of the check completely stalled out, and was single-handedly. It didn't take anything down, thankfully. It just made my whole environment really, really slow for about 2 hours while I went and played whack-a-mole for a while and used cluster shell to try and go on all those machines and close it out. So that was exciting, but that's the one danger of automation, is you can automatically break your entire environment if you're not careful. And then one other thing, and I actually brought this up in the developer meetup this morning, is one thing that would have been super, super helpful with Nagios Core is that I wish it had host group exclusions, to where I could say, apply this check to everything that's a MySQL server, but don't apply it to MySQL masters or something like that. It would have been awesome, because I like to keep things location agnostic, and I don't want to exclude individual hosts, because I want to keep my group definitions the same no matter where they are. That model's actually proved great, because we spun up a North Charlotte Nagios instance, and all I had to do was pull down my Nagios configs, create the symlinks to the version controlled directories, and drop in my hosts in the directory, and pretty much everything worked. So it worked pretty well in terms of spinning up new instances. The other thing I learned with that is that I still love Nagios Core as, people have said it before, it is a monitoring framework. If you know how to connect with it and interact with it, you can do pretty much whatever you want to do with it. And it's just got great tools to plug into it and connect into it, and kind of the sky's the limit. And if you can imagine it, you can probably do it with Nagios. All right, and that is all I got for this presentation. So I want to thank you guys for joining. Hopefully I didn't put you to sleep through that, but we'll open it up for questions. So.
Do we have any questions? Start over here.
Hi. The Grafana graphs that you had, the red and the yellow bars, is that like a part of Grafana? Like, is that some sort of threshold, or I've never seen?
Oh
that
yeah,
before
so
in
that's
Grafana.
it's just built into the interface. Being able to draw threshold lines on there, you just punch that in there and manually configure it. So I do have to manually go in and look and see what does Nagios have defined as the warning and critical thresholds. But I basically just port that into my dashboard when I'm setting it up and say, okay, draw a line at 30, draw a line at 40, and it just does it for me. So
Cool. And also, I was wondering, the Thruck, it offers some other features that Nagios XI or Nagios Fusion?
Great question. I forgot to go into that. So know that I am a huge fan of Nagios XI. I think it's an awesome product, and like things like reporting in particular, if that's a big need in your workplace, that's the tool to go for, as opposed to building it all yourself. The reason I didn't choose XI for our situation is the split data centers and everything being clustered across 2 locations. We needed to be able to just view everything as if it was one list. So like when I want to view the status of an entire cluster, I need to see it all at once. Or if I'm going to submit a command, I need to be able to just do it all at once. It just, from a management perspective, we kind of had to go that route. But I've told them, I said, if you can somehow have 2 locations feeding into the same NDO utils backend and have XI in front of it, I said, I will buy that. It just didn't have that multi-location ability to bring it all together into one view. The other thing is that there's still kind of this stigma around Nagios where people are like, I don't want to touch it, it's scary and dark and Linuxy and whatever. And so really there's like 4 of us that actually use the Thruck UI, and we're all kind of Linux geeks, and like it's fine. I mean, nobody loves it, but it functions for what we do.
And one more question: the custom script that you have to get the graphite data to Carbon.
Yep.
Is that something that's open to the public, or?
There's probably no real reason I couldn't open source it. It's honestly, it's like if I pulled out like our environment specific stuff and just made it into a simple command, it'd probably be 100 lines of code.
Sure, yeah. Or have Nagios actually like bring that in as a tool for.
Yep. Yep.
Cool. Thanks. It's a great talk.
I was thinking about the Nagios the host group exclusion. How I solved that type of problem is like in your example, I'd have MySQL slaves, MySQL masters, and then a host group that included those of MySQL.
Yep.
And so if you just needed a subset, you specified the subset. If
Yep.
not, you had the whole thing.
Yeah, what I ended up doing is kind of making those groups a little bit more granular and a little bit more specific, more so than I had originally wanted to, but it did end up having to be the best way where it's like, okay, make the groups more specific and then just layer them on top of each other.
What I'd like to see is a host group hidden. Because when you start doing all this granularity, when you go to the host group view in Nagios, you got all these host groups. I don't care about all the granularity. I just want to see these specific ones.
Yep. Yeah, and to be honest, we actually don't really use the host groups view all that much. We end up just going to the kind of the main status page in Thruck, and then we just build a compound search to basically look at what we want. So.
Any other questions?
Yeah, one over here. Oh, no, over there.
You mentioned the term PagerDuty. I assume you're talking about the cloud service.
Yep.
Why did you go that way, and how did you integrate it?
You know, it works great for people's stigma and not wanting to interact with Nagios whatsoever. For those people who don't want to touch it, especially like our network operations guys, for their alerts, we just send them straight to PagerDuty, so they immediately get the alert on their phone. And then I also have a poller running every minute, so that if you respond to a problem in PagerDuty, if you like acknowledge it or resolve it in PagerDuty, it will propagate back to Nagios and mark the problem as resolved. So, or acknowledged, I mean. So PagerDuty has a pretty decent API that's not terribly difficult to work with. So I just set up a cron to kind of have the two-way integration. Because we keep our Nagios instances closed, like we don't want to open them up to the outside world. So we figured, all right, from talking to the PagerDuty support, they said if you just create a poller, you can grab the data and then feed it back. So.
Hi, you shared a few details about your automation framework, how it is all done. How are you managing this framework? How are you managing the network inventory with the framework that you have? So networks are not automated through Puppet or Salt.
Correct.
And storage devices too, like storage hardware devices too.
So as far as the network devices, in our infrastructure, that actually doesn't change very much, and that isn't terribly dynamic. Mostly what we're spinning up is, we do spin up hardware servers, but we spin up a lot of VMware servers, and we've just started spinning up OpenStack. But as far as like routers and switches and UPSs, I do have just a web tool that basically I just plug in what I need and punch it in, and it just generates kind of an SNMP-based config for that network device. And that's pretty much how we add new hosts for those. So they're not automated. But we just have kind of a web tool that can say, okay, here's my list of hosts, and here's what groups I want to have them in, and it just spits out the host configs.
And when you said the load balancer are software-based load balancers, not the hardware load balancers?
Yes, I think we're using like a HA proxy. So.
Thanks.
Anybody else? All right, with that, can we put our hands together one more time for Mike Guthrie?